Hello all, good evening.
Good evening.
In the last session, till where we have discussed, did you draw any architecture for this? I told you to draw the top level UVM architecture for master and slave. So today we are going to discuss on remaining files. Okay, so in the last session we have completed sequence, sequencer, sequence item, driver, monitor, and agent. Okay, only these are completed at master site. Okay, so today we will complete the scoreboard logic environment for master and top level test and test bench.sv, and also slave side how the data is transferring from master to slave. Okay, so these things we need to check. So coming to the, do you have any doubts in the before session? Do you have any doubts? Hello. If you are not interested, we can leave the session. No need to discuss. You can go through the previous recorded sessions if you are not interested. Okay, you sit silently. I will also sit silently. Don't you respond? Do you have any doubts from the last session?
No, ma'am.
AXI specification clearer? Okay, I don't want to waste my time. So here Coming to the master side, agent, master agent, access slave agent, and master agent, agent top level. So what we connect in the agent, whatever sequence sequence will be sitting, sequence is seated in the agent, sequence to driver. The connection should be using the TLM port from sequence to driver via sequencer, but through the sequencer we won't connect. Okay, and DUT to monitor. Okay, so these three things will sit in the agent, three components. So class, name of the class AXI master agent extending from the UVM environment, component utils, and create the instance for the class name, and constructor, new constructor, and build phase, run phase by using the extern keyword, so that we need to declare actual function uh, outside the class. Okay, so here it's a class constructor, and in the build phase need to call the super dot build phase, because everything is predefined in the super phases only, right, in the parent places. That's why we need to call super dot build phase. And here how to create the instance for agent, and task AXI master run phase. In the run phase, UVM top dot print topology. UVM top dot print topology means it's a task. We are calling this method in the run phase. We need to check where the UVM top is there. According to that, just calling here the print topology method. It's a reporting mechanism where we print the data in a table manner, in a tree type. Tree type in the sense hierarchy we will get. That means suppose agent. Within the agent, there will be sequence, driver, monitor. In the driver, what are the sub functions? In the sequence, what are the sub sequences, sub test cases? In the monitor, what are the sub task? So like that we will get the topology. In the environment, we will have the agent scoreboard. At top level test, environment will be the sub, right, like the top test bench.sv, the sub levels of test, environment, agent, like that. Okay, so everything will be printed in a topology. So that's why here we are calling UVM top.print topology, so that it will follow the order in a hierarchy way. Okay, so next, after agent, AXI master agent, this is what top actual agent. Here it's a top, just a top level. After top level, test bench. Okay, so coming to the agent here, AXI master agent extending from the UVM agent, it's a component. So UVM component is factory registration, and here config, whatever agent config is there. First of all, we need to check the configuration file. So what exactly we write in the configuration file? Based on your customization, whether this agent should be active or passive, whether scoreboard should be enable or disable, or coverage should be enable or disable. These things we will check in the agent config file. Okay, so here AXI master agent extends UVM object. It's an object configuration file. So config is not an object, but here we are extending from the UVM object. So that's why need to declare with the not declaration, need to create using the object utils. Okay. So to count variables, to count the monitor side and driver side, and also write, read flag, driver mode, delay cycle. These are just temporary variables. Okay, so and here if you see interleave, write interleave, read interleave, write out of order response, multiple order transaction. Okay, so Out of order transaction and multiple order transaction we already discussed. Can you tell me what is meant by interleave concept in AXI? What is meant by interleave concept in AXI? Okay, what is meant by out of order transaction and multiple order outstanding transaction? Can you explain? No idea. Okay, interleaving concept means here we are doing the multiple transactions. Multiple outstanding transaction means where we can initiate the multiple transactions without waiting for the response. Okay, so AXI allows the multiple read write transactions which are based on the independent channels. The channels are independent, so parallelly we can do the write and read operations. Okay, so it can be issued before previous ones are completed, right? Because we no need to wait until the previous one is completed. Okay, so how we can identify those transactions where these transactions are running parallelly and multiple transactions are running parallelly without waiting for the before transaction just going to the next transaction. But how we can identify means through the id. There will be a transaction id, so that we can identify it just assigning id to the each transaction. Okay, so like thread IDs, we can call as a thread IDs, so that the data for these transactions can be written in a non-sequential manner, because there is no sequence of transactions. It's just a non-sequential manner based on whatever the ID we assign. Just we get just get to know which transaction it is, so that we can recognize the transaction based on the ID. Okay, so in the same way, whatever these transactions are returning in a non-sequential manner, that is what we call as a interleaved. Non-sequential manner is nothing but interleaved. That means as long as the data for each id remains in order, it just doing the transaction, right? That means AXI master can issue the multiple number of transactions with the different ids. Okay, so AXI slave can respond with the data from those different transactions in any order. Right side any order, slave side also any order. Okay, so master side whatever the multiple transactions it is issuing, slave side also it is responding for the multiple orders. Okay, irrespective of uh, whatever that sequential manner, whatever. Okay, so but for each id the response must be in order. Okay, no reordering with the same id, just like how the response should be taken from the slave. It will be dependent on the order. Okay, id, based on the id. Okay, so why the interleaving concept is mostly important means just to improve the throughput and the latency, nothing but delays, to reduce the delay. Okay, so whenever the bus active, even if one id transaction is stalled, it just keep the bus active. Okay, so that is what interleaving concept. Did you understood? Suppose imagine like there is a sequence from the master and slave is there. Okay, so there is a sequence from master. The transaction is a, one transaction is a. Okay, and it have the address like 0 into 1000, suppose. Okay, and the burst length, the data will be transfers in terms of burst, right? So the burst length is 4 bits, suppose. Okay, so the transaction name is a, burst length is 4 bits, address is some address. We need to assign the ID to that particular A transaction. So ID will be 0, suppose. Okay. And next transaction B. For B, address is some X address. Burst length is some 2 bits or 16 bits or 8 bits, whatever. Now the ID will be assigned here. Suppose ID is a 1. So for transaction A, ID is a 0. For transaction B, ID is 1. Okay. The master will send these two requests to transactions with different IDs. Okay, getting the point? So that the slave can return the data in an interleave fashion. How it will return the data in interleave fashion? Based on the beat. Okay, suppose first A transaction A having 4 beats. Here transaction A and transaction B. Transaction A having some ID 0 and 1, and here it's a X address 1000, X address 2000, whatever. Here suppose it's a 4 bits and here it's a 2 bits. Okay. So suppose it's a read transaction. If we think the transaction name is a read transaction A, read transaction B. Okay. So the slave can return the data in an interleave fashion. How the slave will return in the interleave fashion? First of all, it will consider the beat. Beat means based on 1 bit, 2 bits, 3 bit, 4, 5, 6. Okay. For each bit, it will assign the number. Okay. So 1 bit means it will be coming in a ID number 0. Okay, 2 bit means it will be coming ID number in a 1. 3 bit means it suppose ID number is 1 again. And for remaining all are is zeros. So how we are getting this value? Based on these value, the data will be considered based on the bit and based on the ID. Okay. So suppose here A of 0 is sending. 0 means A of 0 because here read A transaction, read B transaction. Okay. So in first line, when bit is 1, the ID number is 0 here. So that A of 0 is transferring. Like that bit is 2, suppose ID number is 1, here B. B means first bit in B. In B0 data will be transferred, 0th bit. Okay, like that next 3 ID also 1 only, so it will pick this read operation. ID is 1. So now whenever ID is 1, the read B operation in B, what data it will transfer? Bit 2. That means first one, B of 1, already B of 0 bit has transferred, B of 1 data will be transferred. Okay, now for in fourth bit, ID number is 0. So here ID number will go to here. A. In A, what bit it should be transferred? What data? A of 0 is completed. Next one is A of 1. Okay. And again 0 ID. 0 ID means again A transfer only. Again in A transfer, second bit of data will transfer. A of 2. Again 0. A of 3 will be transferred. Okay, third bit of data A of 3 will transfer. And next here seventh, suppose 7 is there. Again here 1 is there. 1 means what? B. B means B of 1, 0, B of 1. Okay, like that B of 2. You need to check in terms of bits also how much burst size. Based on the burst size, the number of bits will be divided. Okay, so this is what the interleaving concept. Okay, based on the ID, one bit, one transfer is completed and second transfer and then third transfer. Okay, so here the responses of ID are completed first. Okay, suppose here What responses are there? 0 ID, 1 ID. Suppose responses of ID 1 are completed first. Okay. So responses of ID 0. This is for ID 0 and here we have ID 0. So ID 0 will continue afterwards. Okay. Here first 1 is completed here and then 0. Suppose if 1 is completed here, after 0, 1 will be continued. But here, if I didn't take this 1, till here, ID 1 is completed. Okay, ID 1 are completed first. So 0 is still continuing here. Okay, so within each ID, the data is in order. In response side, response should be in order. Transferring right operation can be any order based on the ID number we can identify, but response side it should be in order. Okay, so that's why it is a like this interleaving. That's what we call as a interleaving. We need to follow some rules for interleaving in AXI protocol. Okay, what are the rules? First of all, out of order responses are allowed. Out of order response means what? Same multiple transactions, there should be order. Okay, so out of order responses are allowed across IDs but not within the same ID. Did you understood? Here same ID is there, 3 same ID, 0 0 0. Okay, so here out of order response are not allowed. That means each ID data burst must appear in the correct sequence. Number of IDs can appear any sequence, but whatever the data flow here 0 0 means B A0, next again next 0 A of 1, again next 0 A of 2, again next 0 A of 3, like that each ID's data burst must appear in the correct sequence. Okay, so that master should track with the responses belong to the which request using the ID tags. Okay, so that's why maximum number of outstanding transactions is typically limited to the outstanding transaction depth based on the depth in the slave. Okay, transaction size will be there, right? The depth value. Based on that, it will be dependent. Okay, so here you need to understand few points, like a few terminology, like first of all, out of order transaction. Out of order transaction means transactions issued but not yet completely. Okay, transaction id means it identify a particular logical thread of in the bus, in the communication. Okay, and next you need to understand read or write interleaved depth. What is the depth value? Depth value is nothing but it just indicates how many separate write read transactions can be interleaved. Okay, did you understood everyone? Interleaving means just allowing the multiple outstanding transactions with different IDs to serviced out of order. Okay, so in order within ID means just in order whatever the transaction happening in the order with ID number. That means AXI have the mandatory, like AXI mandates the data for the same ID whatever to be written in a order. Okay, did you understood? So that mainly we use in the processor related SOC designs related only. So right side interleave, read side interleave, right side out of order response, next a multiple outstanding address. Okay, right side and read side. Next to virtual interface, create the virtual interface and UVM active passive enum is active. I already shared the PDF for UVM, right? In that if you see there will be syntax, proper syntax. Okay, so how you can define the agent is active or inactive? Just we need to write UVM active passive is a just name. You can mention any name. It's a user defined name. Okay, is active. Whenever is active is equal to 1, it's an active agent. Whenever is active is equal to 0, it's a passive agent. Okay, next here just a constructor and end class. After agent, it's a config file. In the agent, we need to make the connections between sequence and driver, DUT to monitor. Okay, so class AXI master agent extends UVM agent component utils. Need to create the component and created the config file, one config file, and a monitor sequencer driver, the low level blocks. Okay, and return the class constructor build phase and connect phase. Okay, build phase means it just used to create the instances of config or remaining subfiles. Connect phase means where we can make the connections between the low level blocks to the higher level blocks. Okay, that's what connect phase. So this constructor is just to create the class, and in the build phase, if you see config file get data. So you already know how to write the set method and get method, right? So if UVM config db hash AXI master agent config, it's a class name, scope resolution operator get this, that too, this means in the component. Okay, in the class component we need to mention it as this. If it is an object, then null, right? So this comma, again class name AXI master agent config name comma instance name. If condition is satisfied, then we'll get the any without any error actual functionality it will be doing, or else UVM fatal error config get cannot get the config data. Okay, have you set it? Just if you see here, cannot get n config data from UVM config db. UVM config db, where do we have the file? Just now we have seen UVM config db file. It's a master agent config file. UVM config db file here, AXI config file. It is master agent config file 1. Agent config slave agent config master driver master agent sequence stop scoreboard master. Okay, here from UVM config db. UVM config db just a name. It just a default name. It's a syntax. UVM config db. M config is the name here. Not for this. Okay, actual config, if you see here, AXI environment config file extending from the UVM object utils, and M agent. M agent has M agent is equal to 1. It's active agent. Here also M agent 1 is equal to 1. Master agent 1, master agent 1. Both are equal to 1. That means active agent. And slave agent is equal to 1. Slave agent is also active agent. So that sequence, driver and monitor 3 will be available. And virtual sequencer is equal to 1. That means where enabling the virtual sequencer. Like that, you can enable the scoreboard or disable the scoreboard. Coverage analysis, you can enable or disable the coverage, like that. Okay, so here collector in the sense monitor. Okay, where just collect the data from the DUT. So m collector 1, that means master collector 1 for master agent 1. Okay, next scoreboard collector, sorry, slave collector. And next, if you see, scoreboard is enable or disable. So here we are making scoreboard is equal to 0, scoreboard is disabled. Okay, and next to dynamic array configuration handles. Dynamic array configuration handles means here AXI master agent config, one config for AXI master agent, and created the config instance. Okay, and for agent 1 or for master 1, there is another agent config 1. Okay, total 3 config files. Master side agent config and agent config 1, slave side agent config only, and top level environment config. All these 3 sub configs we are connecting in the top level environment config. Okay, so these 3 configs we are calling in the top level environment. Number of dots is equal to 1. It just is small, the constructor just creating the string. And here AXI environment config extending from the UVM object. Here actually AXI environment config extending from the UVM object, that is one class. And in the second class, it's a sequence, agent env config sequence. Okay, here if you want to write, you can write, or else we can even avoid this. That's not a problem. Here just calling the int number of sequence transactions is just calling. There is no use of this. Okay, we can avoid this logic. Okay, next, these. So here master agent, whatever the master agent is there, here mconfig file, these are just here we are not calling any instance and all, just to print the statement. Okay, so it's not any calling function. Okay, so if it is having the data, the config file having the data, it just get the data, or else it is asking have you set the data, whether in the config db the data is set or not. So where we are getting that config data from AXI m agent config h. Okay, so here if the fatal error is not printed, then what should be connected in the build phase? Actually in build phase it doesn't do any connection, it just create the components. Okay, so if it is an active agent, if you observe here, normally only monitor is connected, monitor is created. Okay, 27th line, AXI m monitor. Okay, before this, just go through the AXI monitor block, master monitor block. Here 1.2, master monitor 1.2, and monitor master 1. You just change the name, no need to write master monitor 1 and 1.2. Just write master and master 1, that's it, because remaining all written agent 1, environment 1, right? In the same way, just write master monitor 1, that's enough. Okay, so it's a one master, AXI master monitor 1 extends UVM monitor. Okay, don't confuse. After entire test bench development, first of all, understand what is the use of two masters and what is the use of one slave. Why we are not using single master? By using the two masters, what type of operations we are doing with the one master, and with second operation what we are doing. Okay, because here total test plan, if you see the test plan, total how many features are there fixed done, that means single transfer, in the burst transfers, increment, wrap, aligned, out of order transaction, outstanding, multiple outstanding, atomic response, interleaving concept also there here. So you need to understand master 1 which is focusing, master 2 which is focusing. Here in the master 1 mainly focusing on the interleaving concept and the burst transfers. In the last session, not burst transfer, not increment wrap, out of order transaction and multiple outstanding transaction. These three it is focusing. Master 1, okay, whatever the remaining master is there, that is focusing on increment of wrap of fixed. Okay, I will show you those also. Okay, these two masters are focusing according to these requirements. Okay, so that the data is sending to the one particular slave. Okay, so here our concept is master 1. Master 1 is equal to remaining agent and environment, not agent 1 and environment 1. Here monitor 1.2, if you see here monitor 1.2 is equal to the agent 1. Okay, so don't confuse. So here class AXI master 1 extends UVM monitor, component utils for master 1, and virtual interface. You know how to create the virtual interface through the mod port and clocking block, right? Next, creating the AXI master transaction 1 where we get the virtual interface data to the transaction class, that is AXI XT and H, and configuration file. For config 1, created one config file, right? Three config files are there. um, Three config files are there. Agent master side are two config files, slave side one config files. These three config files are connected in the top level environment config file. Just now we have seen. Okay, so now analysis port. Why do we use the analysis port? Because sequence to the driver means it's a one-to-one connection. So directly we can use the TLM port and do the connection. But monitor to scoreboard to coverage, monitor to sometimes if you use the RAL model, it contains the predictor. Okay, these many things, these many connections are there. So to connect one to many, we use the analysis port, right? So UVM analysis port, here extend function, four functions are there: constructor, build phase, end of elaboration, run phase. Okay, and four tasks are there: collect the data, because monitor means majorly collecting the data, write data, read data, report phase are there. Four phases. Okay, four tasks. Okay, so first one is a constructor. You already know how to write the constructor based on the connections. Majorly for sequence there will be only what sequence, TLM, but here we don't have any sequence connection, right? For driver we have the interface connection, and here also for monitor we have the interface connection. Okay, so but that is different, and in coming to the UVM flow it is different. Okay, so function new AXI master 1, scope resolution operator new, here just creating the class. Okay, next, build phase. In the build phase, majorly, what is the main functionality of the build phase? We need to get the config data and need to create the components. Okay, so here getting the config data, right? And end of elaboration phase, run phase. In the main run phase, collect the data. Collect data means how do we collect the data? Whatever the DUT have, the data we need to get to the transaction data. So here if AXI master config write read flag is equal to 0, based on the flag signals we are enabling the write data. Just we are controlling the write data and read data here. Okay, so AXI m agent config dot write read flag is equal to 0, 0. Write data is write data task is enabled here, and based on the flag 0, 1 read data, based on the flag 1, 0 write data read data, which is keeping in the fork join, both will done parallelly. Okay, so now write data task. So what is the write data task? We need to create the instance first by using the create method. Okay, and how to get the data? See, AXI virtual interface dot master monitor. Okay, and wait till AW ready is high and valid signal must be high. Okay, whenever AW signal is A ready signal is high, AW valid signal is high. Okay, then write address which is getting from the virtual interface, which is getting from the DUT, sent to the AW address transaction. Okay, and ID is sent to the AW ID, length sent to the length, size to transaction size, burst to transaction burst. Okay, this path you already know how to mention, right? Virtual interface dot master monitor, which is nothing but the mod port name. Mostly we put the mod port name, and clocking block also you can put, or else only mod port also enough, because directly mod port only it will be connected. Inside the mod port there will be clocking block, right? That's why just mod port connection also fine. Okay, next info statement, UVM info. In UVM we don't have the dollar display, dollar monitor, this type of system task we don't have in UVM, right? It's just info statements, fatal or warning error statements will be there. Okay, so second one is based on AW length, based on again second for second transaction, W ready AW. Okay, this is for address, and second one is for data. Okay, W valid, nothing but write data, W ready, so that ID signal is getting based on write data. Okay, 32-bit data. And next, response, write response. So whenever B ready is high and B valid is high, then B ID should be sent to the transaction ID and response. Okay, response data getting from the DUT to the transaction. Okay, next to see here, monitor port dot write. Okay, in the TLM port, I already explained the concept. You already gone through the recorded session. Based on the consumer and producer, based on the target and initiator, we use the put method or get implementation method, get method or put implementation method, right? But here in the analysis port, we use the write method. Okay, just write method. So simply putting into the analysis port, so that from scoreboard or from coverage or from configuration DB file, we get the data. Okay, and check. Okay, and read data also same, just create the instance for read data and read address. For read address, AR valid.
Ma'am,
AR valid.
if
Yeah,
we
tell.
use get or put method, what's happen?
Hmm. Get or put method, actually when do we use get and put method, can you tell? In
Ma'am, in
UVM,
the
we
place
don't
of
have the get put method directly, because when both are working as an initiator, then we use the get and put method. Okay, in the middle, we have the UVM FIFO. UVM FIFO is the mediator between two initiators, where it will work as a another what? Initiator target. Okay, FIFO will work as a target both sides. Then you can put directly put method, get method. Other than put get method, you need to use the implementation port. Put and put implementation, get or get implementation based on what the target you consider. But here in this case, by default, it's a write method. You can't use put get methods because it's a simple. Just if you use put get method, how it will work? It's like a basic mailbox concept.
okay,
Okay, analysis port means write method only. We don't have put get methods. even in UVM, we don't have the put get methods directly. We have the implementation method, because every time one should be the target, one should be the initiator. Okay. So here address should be assigned to the transaction address, and ID, read ID, address read, and length, size, burst. So that read address completed, monitor site. And next data. So 0 to length. So how much total length and how much data. So based on the dot master monitor, here ready signal should be high. Wait till ready signal is should be high and valid signal is high. Then ID is transferred to the read ID, or data is transferred to the or data. Okay. Master last. So if you see here last means it just indicate the last transaction. Okay. And the write monitor put write method. Again, by using the write method, we are just putting into the analysis port. So in the scoreboard, by using same write method, we get the data. Okay, understood till here? It just a report phase. Report phase is nothing but to print the output at the console. Just that is what report data. Okay, I already shared the document AXI, this code and another VIP code for AXI. You just take the files and you can put in the EDA, or else you can do it in the Quest sim. Okay, and try to do the verification. Next, after master 1, monitor 1, sorry, monitor 1, agent here. Now agent, see here. Class AXI master agent. I have explained this. This is what AXI master monitor, which we have seen now. This one AXI master monitor. Same class name. We just write there. And sequencer driver. Okay. So whether it is active agent or passive agent. So if you see 27th line, AXIM monitor is the name of the instance of the monitor, master monitor. Okay, is equal to AXI master is the class name, type ID, create. That is how we create the instance, right? This comma AXI, this we can give the name like this, or else you can put first name comma this whatever. Okay, if AXI, this whatever the instance name dot is active is equal to UVM active. If it is active agent, then these two also will connect. Sequencer and driver will connect. If it is a passive agent, sequencer and driver is not required. Okay, only this monitor will connect directly. You no need to write these two. Okay, if UVM is active is equal to UVM active, then these two connections should be done. That's what the clear point here. If it is equal to passive, no need to write these two blocks. Then only this AXI this monitor will be connected to the DUT. Okay, so if you see here, driver and sequencer both are creating in the agent, because these two are sub blocks in the agent. So this is how we can create the driver block and sequencer block. Okay, so in the build phase we just created. Okay, monitor is created, driver is created, sequencer is created. You already know how to create by using the create method. In UVM, we use the create. In system verilog, to create any instance or object, we just use the new method. You already know what is the difference between new method and create method. Okay, by using the create method, we can override any class, component name or object name with the with any other name. We can just override directly without copying, without doing any polymorphism concept or without changing entire flow. Okay, we just override the name by using the create method. Okay, so that is what in the build phase. Did you all clear till here? Any doubts? Any doubts still here? Okay, coming to the connect phase. See here. In the connect phase, if AXI agent is active is equal to UVM active. Okay, if it is a active, then this is how we are doing the connection. AXI MDRVH means what? It's an instance for driver, right? Dot sequence item port method. Port export. One side it should be port, one side should be export. Export means implementation. Implementation details will contain in the export. Okay, port means target, right? So here this is how we use the connect method. Okay, sequence item port dot connect of sequencer dot sequence item export. One side port, one side export. Based on this, we need to use the get implementation port in the driver. So go through the driver code now. There is the driver AXI master driver. Master driver. So if you see here, get implementation port will be there in the driver. See, sequence item port sequence this line sequence item port dot get next item of request. Okay, in sequence again, in sequence there are a lot of sequences like fixed bus increment sequence. So here in bus increment sequence, it's just doing the start item of request and request or randomize and sending to the DUT, and once get next item is done, finish item. Okay, this is what the transaction flow and the port connection, TLM port connection. Did you all understood? Clear? Any doubts?
No, ma'am.
Remaining?
Like from last part you explained now in agent where you are creating like last one.
What?
Here only like you are we can't write the driver component here. Means we need to like call the driver from here to another means this was not understood properly. Like connect phase, what is the use of here?
What is the use of connect phase?
Means
Okay.
in agent.
Because in the agent only it is these components are sitting, right? We have sequencer, driver, monitor, scoreboard. Sequencer, driver, monitor will sit in the agent. Again, agent plus scoreboard will sit in the environment. In the top level test, sequence plus environment. This is what the flow. So that's why
So you connected from here to driver, like from agent
in
to
the
driver.
agent, first I have created this agent. Okay, this is the agent, AXI master agent. Okay, in AXI master agent, in the build phase, we have created 27 line, 30 line, 31. 27 line is the monitor, 30 line is the driver, 31 line is the sequencer. Okay, so here sequencer is created, driver is created, monitor is created. Okay, now we are writing the statement, like we are writing the condition. If it is a active agent, then there is a connection between sequencer to driver, because you know what is the difference between active and passive. If it is an active agent, sequencer driver will be enabled. If it is a passive agent, only monitor will be enabled. That in that case, if else block will be executed. In the else block, only monitor is connected. In if block, sequencer and driver also connected. Did you understood? So
It's a sequence
yes,
driver
right.
and monitor also connected here. No, it's three will be if active, then
Yeah, active means 3 will connect. Passive means only monitor will connect to the DUT. Hello.
Yeah, yes, ma'am. Got now.
Okay.
Yes.
I think you're just joined in a group of, right? Okay, see. Here monitor is it, if only one monitor is connected means it's a passive agent, but here it's an active agent, so the 3 components are connected in the agent. Okay, build phase means just creating the component. Connect phase means making the connections between components through TLM port by using the TLM ports. Okay, so here sequencer to driver means TLM port is enough, but monitor to scoreboard, monitor to coverage, monitor to another block checker or predictor, whatever. For this, TLM port will not work. For this, analysis port is written. Analysis port we need to use one to many, just by using a write method. Before I shown you, right? A write method. By using the simple write method, we can just transfer monitor to scoreboard, monitor to coverage, remaining. Okay, no need to write put get methods. But here sequencer to driver, based on which is a port, which is the export. If it is a port, then port to export. If it is export, then export to port. Based on that, we need to connect in the TLM port. Okay, so if you see here, sequence item porter, driver sider, sequencer is a exporter. Okay, so that is how we make the connection in the agent. Clear?
Yes, clear.
Okay, next environment. In the environment, AXI environment. In the total, this is AXI environment. Okay, before AXI environment, we'll discuss AXI master environment. AXI environment config, AXI master. Okay, AXI environment is a top level. In this AXI master agent to top. Okay, and top one and a slave top is connected. 3 environment. Okay, before environment, we will discuss the virtual sequence. AXI virtual sequence and AXI virtual sequencer. Actually, what is meant by virtual sequence? What is meant by virtual sequence? Before I told you virtual sequence is nothing but it is a group of sequences. The group of sequences we connect in a one virtual sequence, right? So if you see here, AXI master sequence, AXI master sequence. AXI master sequence. Here in this AXI master sequence, there are number of sequences, right? Master sequence base sequence is there, and rand sequence is there. So sequence 1, sequence 2, and third one AXI master sequence 3, and here increment sequence, like that number of sequences are there. So all these number of sequences we will put in a one virtual sequence, like that. In the virtual sequencer there will be n number of sequences sitting in the virtual sequencer, master side, slave side, all master. There are two sequences for master, one sequence for sequencer for slave. So these three sequencers will sit in the virtual sequencer. Okay, like that. AXI master sequence is the sequence 1 is the slave sequence. These three sequences will sit in the AXI virtual sequence. Okay, so here class AXI virtual base sequence extending from UVM sequence. It's a parameterized class, so need to pass the parameterized UVM sequence item. Okay, so it's object. Sequence and sequence items are objects. Okay, so that's why we need to create with the object, and created the instances for sequencer. Okay, and created one virtual sequencer. Through this virtual sequencer only we connect the remaining sequences, physical sequences. Okay, so AXI master rand sequence. Okay, that's a sequence 1. AXI master rand sequence 1. Sequencer sequence 1. No, slave side 1 sequence is there. Okay. In that there are fixes. Just now I have shown you, right, in the sequences what are the number of sequences are there. So in that there are one fixed sequence in the master side, sequence 1, another fixed sequence 1 master 1 side, sequence 1, slave side fixed sequence. So 3 sequences, and then increment sequence, and then wrap sequence. Okay, in each sequence 3 subsequences are there. So all these subsequences will be connected in the virtual sequences. Okay, AXI environment config, and AXI virtual base. This is what the class name is, creating the class constructor, and AXI base sequence main body task. Why? Because from the sequence to generator, how the transfer will be done through the body task only. So here the main sequences will not be directed to the driver. Through the virtual sequence, it will be connected to the sequence, then it will be directed to the driver. Okay, so if you see here, main body of the virtual sequence, if UVM configure get null, so here null is there. I already told, for objects we use the null, for components we use this. Okay, so get null comma get full name AXI environment config comma instance name. Okay, so here master sequencer, for sequencer instance, sequencer 1 instance, and slave sequence instance. New of environment number of duties connected. If you see here, number of duties before some constant value assigned to the number of duties. If you see before, just check, just count the value just for the counting purpose. Okay, next dollar cast virtual sequencer comma m sequencer, just typecasting, and error, body error, error in dollar cast of virtual sequencer. And for each master of I sequence, for each sequence of I, virtual interface dot master sequence I is assigning to the these sequences. That means virtual sequence data is assigning to the main sequences. Okay, for sequence 1 and slave sequence. Okay. Before that, let me explain with a simple example, you will understand. Okay, if you see here, there are two sequences. Okay, class sequence A, which is extending from UVM sequence, and class sequence B. Two sequences. For sequence A, there is a task body, and sequence B, there is a task body. However, in the AXI protocol, we have written the fixed sequence and increment sequence, wrap sequence. Like that, here sequence A, sequence B. Okay. So these two sequences are, here there is a virtual sequencer. Why? Because these sequences are connected to the driver through the sequencer only, right? So in the virtual sequencer, the sequencer B are created for sequence A, sequence B. Okay. So here sequencer A is created instance for the sequencer A. Sequencer B instance is the instance for the sequencer B. So sequencer A, sequencer B are classes. Okay. This is how we create the virtual sequencer, where in virtual sequencer we keep the instances of those sequencers. Okay. And coming to the virtual sequence, class virtual sequence extending from the UVM sequence. Okay. So object virtual sequence and virtual sequencer, V sequencer, task main body. Okay, this VIP, whatever the task main body is there for the sequencer, same task body. Sequence A instance, sequence A. For sequence B, SEQB is the instance. So created two instances here. Okay. Now how the connections here, see. Sequence A dot start of virtual sequencer dot virtual sequencer of A, by using the start method. Even in the sequence also we use the start method. Whenever the start method is initiated, it will transfer the data to the, it will make the connection to the sequencer to the driver. Okay. So sequence A dot start of V sequencer dot sequencer A, and sequencer B dot start of V sequencer dot sequencer B. This is what actual connection. Okay. For UVM students, you will be getting 5 lab sessions on UVM. Okay, on topic wise, for agent and for lab session, in the sense for agent, TLM ports, factory registration, virtual sequence, virtual sequencers, and these RAL model. Okay, within these 5 sessions, you will understand top, like how to connect the coding. Okay, whatever I have shared the PDF, you can go through that PDF. You will get the clarity from that also, or else you can prefer the recorded session. In the recorded sessions also I have explained very clearly. Okay, so you will get the clarity from there. Okay. So this is how we connect the two sequences through the virtual sequencer. And in the main test, how the virtual sequencer is connected in the agent in the top level test. So component util test, my test component util, two virtual sequencers, virtual sequencer and virtual sequence, both must be connected in the top level test. And then environment. Okay, and create the build phase for sequencer and environment, and in the connect phase make the connection. Just here we don't use any TLM ports like that. In the connect phase, TLM ports are used just for component to component connection only. Okay, here normally in connect phase we are just connecting virtual sequencer of sequencer A to the environment dot agent A dot sequencer A, because sequencer A is sitting in the agent. Okay, agent is sitting in the environment. That path is enough. Like that virtual sequencer B, what data we are assigning? Sequencer B is connecting to the virtual sequencer B. Sequencer B is the physical sequencer, virtual sequencer should be connected. So what is the path? Environment dot agent dot sequencer B. Okay. Next, in the main run phase, creating the virtual sequence and also a sequencer. To the sequencer, just assigning v sequencer, and by using the start method we just do the operation. Just start method, it automatically redirect to the particular sequencers, and within the sequences whatever we are doing the randomization and sending the, see, this start method will redirect to the particular sequences here, task body, the start item of TR. Okay, so based on these sequences the data will be sent to the driver. This is what actual flow. And coming to the phase dot rise objection, phase dot drop objection, I already told you, whenever number of transactions are there at transmitter side and receiver side, both should be equal. Number of transactions should be equal, so that one should wait, mutual exclusion between the should be there between both. Okay, so that one transaction should be wait to complete for next transaction. Okay, that means driver code should receive all the transactions whatever sending from the generator. Okay, when generator side, driver side, both number of transactions are equal, then there will be no data loss. So that particular thing can be observed by the rise objection and drop objection. Okay, so that is what virtual sequence, but because of this AXI it will looking like very big concept, but just go through this once. Okay, it takes
Ma'am,
time
please
to
send the file that you saw.
this virtual sequencer. Huh?
Yes, ma'am. Yes.
Okay, and for you, if you want to go with the easy flow, first of all, if you want to learn easily the AXI, just go through this one, very easy, simple AXI. Okay, just a monitor sequencer, just 1-to-1 only. Okay, there is no master slaves like that, the simple understanding. Okay, and if you want to go with the complex one you can prefer this. So however we write in the master side, slave side also same. Okay, so slave side I will give you top overview. Everyone understood what is meant by virtual sequence, and virtual sequencer also same, we create multiple sequencers. Actually in the sequencer we don't have any particular code, just a sequencer is a mediator, the mediator logic by default available in the library. So at our side user point of view we don't need to mention any logic for the sequencer. In the virtual sequencer also same, just create the component virtual sequencer and created the sequencers here, master sequencer1, slave sequencer, and config. Okay, like this. Clear? Any doubts still here?
Like, so what is the use of virtual sequencer? I mean, we can use normal sequencer also, no?
Normal sequencer also I can use, but virtual sequences should be connect to the virtual sequencer only. Virtual sequences you can't connect to the normal sequencer.
It's I'm saying ki in place of where you type virtual sequence, there also we can use sequence also, like
Normal sequence.
normal
So
sequence
you
and
want to
sequencer, I'm
use.
saying.
Yeah. So here why we are using normal sequence means suppose here if you see it's a virtual sequence. Okay, where here it's a virtual sequence. Okay, so here by using just one sequence virtual sequence method, by using just one virtual sequence instance, we can connect directly to the driver. But if you do with the normal sequences, this sequence A should connect to the driver, sequence B should connect to driver, sequence C should connect, D should connect. Like if there are 100 number of sequences, 100 number of sequences separately should be connected to the driver. Okay, so without doing like that, we are connecting all the sequences in one place. That's what we call creating some virtual sequence for the physical sequences. That virtual sequence is directing to the data is directed to the driver. That's why for simplicity wise. Virtual sequence block diagram also available if you see in UVM. So if you see here, there is an environment bus agent. There are two agents. One is GPIO. Okay, see here. Virtual sequence. Okay, in this virtual sequence, there are n number of sequences. Okay, bus sequences and GPIO sequences. For this DUT, actually in DUT there are n number of blocks in SOC. Suppose different IPs are connected, right? GPIO, AXI, AHB, or any other bus transfers, everything. Okay, so from all these sequences, we are connecting in a one virtual sequence. So if you see GPIO sequences are connected to this virtual sequencer and bus sequences. In bus sequences, again, there will be hundreds of sequence. In GPIO sequence, again, there will be hundreds of sequence. So these all group of sequences connected to the one virtual sequencer. This blue color is the virtual sequencer, and these GPIO sequences are connected to this blue color virtual sequencer, and this virtual sequencer is connected to the actual physical sequencer, and here this connected to the actual physical sequencer. Through that, it will be actual sequencer is connected to the BFM. BFM means bus functional model, which is nothing but the driver. Okay, here in the bus sequence, there are 100 sequences. All the 100 sequences are not connecting to the driver if you observe. Okay, all the 100 sequences are connecting to the virtual sequence. That sequencer is connecting to the bus agent. Like the GPIO agent will be there, AXI agent, AHB agent, APB agent. Okay, so all related to all IP sequences will be available in one virtual sequences. Based on that, it will make the connection to the sequencers. Did you understood? Same thing we have written in the program here. Here sequence A, sequence B, suppose in bus interface sequence. Like that we will have GPIO sequences. These sequences are connected in one virtual sequence. Again, the GPIO sequences will connect in the virtual sequence. These virtual sequence will be connected to the main sequencer. That main sequencer will be connected to the driver. Same here also in AXI. If you observe particularly line to line, you will note that point. You will get the point. Okay.
Yes.
Any other doubts? Okay. So next master side, just go through again here coverage also coverage cover group. I will explain coverage later. Okay. Once coverage sessions are completed, just very simple cover groups. And coming to the slave side, again slave side slave sequences will be there. Okay, RAN sequence and wrap sequence, increment sequence, slave side, base sequence, and a sequencer, slave transaction, slave side transaction. How the constraints are written here, just go through that. Okay, mainly you no need to go through all the files. Okay, if you want to go with the deep understanding, you just check okay all the file, but try to be very confident in one particular file. Okay, whether driver or sequence or virtual sequence, try to understand very clearly on one or two concepts. Why? Because you can mention in the resume like you have developed the sequences of AXI. In AXI, you have developed the n number of test cases, the test sequences for whatever I shown you before, base sequence, increment of wrap burst transfers. You can mention those things in the resume. Okay, like that you can also mention like you have developed the particular driver block or coverage model. Okay, just mention only particular blocks because no one will develop all the blocks. Even if you go in with the industry, you need to write what is your contribution, what is your role in that uh, particular project. Okay, so like that, take this reference, take this program as a reference. Okay, try to check what just particularly mention the block. Okay, suppose you can mention like uh, verified the particular signals. Okay, like valid signal, you have verified particular valid signal, the data is getting valid or not. Okay, you have written the code for um what signals are there, like size, length, particularly verified the length of the each test, size of the based on burst transfers, like that points, mention those type of points. Okay, so that it will look like okay your actual contribution in the AXN. Okay, based on that you will get the questions, and even no one will ask to write the code and all. Okay, simply detailed explanation how the transfer is happened between master to slave. It's a general question. If you know UVM perfectly, you can answer. That thing you can manipulate to AXI. So in AXI, you know the concept, you know the specification. In AXI, these type of transfers will be there. So the transaction will be happened in this way. How the transaction flow between sequence to driver. If it is a multi-master, multi-slave, we create the number of sequences, number of tests to the connect to the virtual sequence. In the same flow, you need to explain. Okay, whatever the flow I have explained till now, just that will be enough. Okay.
Ma'am, if
If you
multi-master, multi-slave will be there, then arbiter concept will be there, no?
here in
Select the
AXI protocol, we don't have the arbitration concept. That's what we have discussed. It's a independent channels.
okay
It will do the
pipeline.
transaction independently, all transactions.
Okay. At a time, any master can send any slave.
Yeah.
Okay.
Okay. So next, that's what the flow you can explain. Okay. So next, what are things are there? Majorly, you will get the UVM questions on phases. Phases also very important concept. You can explain very detailedly. Okay, that is also the transaction flow. Very logical questions you will get, like how the scoreboard logic can be written to verify this particular test. Okay, how to verify uh, any type of signal, like even here, go to the transaction class. Sequence item transaction. Okay, so maybe you will get how the master lock signal is working. Okay, the protect signal is working, ready signal is working. Based on this only, you will get the questions. Okay, so whenever the multiple masters, multiple slaves are connected, what is the difference between AXI, AHB, how the channels are working in AXI, and in AHB, what are the different phases, how the arbitration concept is working, what is the split retry response, what is the difference between light and AHB. Okay, um, majorly every concept I have covered in AXI, even interleaving concept covered, the cache, CHI also covered by Maheshwar. Okay, anything there?
Ma'am, please send the previous recorded class.
Previous recorded session I need to share. Okay, everyone go through here, slave side also try to understand the slave. If you don't understand, I can explain you again. Okay, I will share you this VIP, the master, this both codes already shared in the group, and I will share the recorded session also. Okay, till here, AXI protocol is completed. Okay, it's up to your understanding. If you can spend time, you can understand more detailedly. Um, Another session is AHB to APB bridge. I told, right? So tomorrow I will be not available because of Sunday. Maybe Monday we will discuss on AHB to APB bridge. Okay, in weekdays we will have one session, Monday or Wednesday, and we will complete the bridge also. Okay.
Please send the all resources.
Okay. Yeah, I will share. Any other doubts? Aditi, Venkatesh, Ashwini, Sweta.
Ma'am, in UVM, that real session is, means you can discuss that one or like it,
Trial
like you
session
done?
I have shared, right?
Yeah, already shared. Like that. some doubt I have.
Okay, yeah, please tell.
Backend and front end, that part like not clear
Backend
for me.
access for front end access. Nothing is there. Backend access means directly the what is that adapter will be connected to the DUT. Front end means adapter is connected to the driver is connected to the adapter is connected to the bus sequences are connected to the driver. Okay, driver to DUT, that is front end door, front door access. Back door access means direct reg sequencers are connected to the DUT. That means whatever the register data is sequences are generating exactly connected to the DUT. That's what backdoor access. I will explain, no problem.
And real model, like code you not explain there. It's only theory is there in these two sessions.
RAL model theory only I have explained.
Okay.
Here, if you see, friend door access means sequence library, number of sequences, register sequences are there. Register sequences will send to the adapter, so that adapter will convert the register data to the bus data. That bus data will send to the sequencer, from sequencer to the driver to DUT. That's what friend door access. Backdoor access means directly this number of the reg sequences will be connected to the DUT, because DUT already reg 0, reg A, reg B, reg C. Here also reg A, reg B, reg C. So this data and DUT data both will be equal. So directly backdoor access means we will connect this register model directly to the DUT. Okay. I will show you clear picture. Yeah, same. Whatever I explained, same. See here, the same register sequences are directly connected to the DUT. That is what backdoor access. Front door access means to adapter, adapter to sequencer, sequencer to driver, like that. Okay. Anyway, we will discuss. We have 5 sessions for UVM.
Okay.
From Tuesday, whole next week will be on coverage. Okay, by next week I will complete coverage. If not completed, even I will take Saturday, Sunday sessions, and I will complete coverage and assertions in system verilog. And next session, UVM parallelly projects, Saturday, Sunday. From next Saturday, not this coming Saturday, Sunday, we will complete the coverage and assertions in next 5 sessions. Weekdays 3 sessions, Saturday, Sunday 2 sessions, so that coverage will complete. Next coming Saturday, Sunday onwards, we'll start the project, RISC-V processor project and UVM project. So that parallelly we will complete the UVM also. Okay, some of you registered for the professional growth course, right? So for professional growth course, you will get the S4C, actually S4C level project. But instead of S4C, I'm thinking to give the DDR5 project, because nowadays DDR is also majorly focusing, right? In most of the JD, DDR is also mentioning as a, like, you can put whole project that will be discussing by the mentor, another senior mentor. So from July 1st onwards, DDR will start. By July end, we will complete the RISC-V processor, not July end, June end, we will complete the RISC-V processor and UVM project. Okay. Yeah.
Ma'am, will you take the RAL CM?
In UVM, that's what I'm telling. By next
Yeah.
week, in system verilog coverage and assertions topics are left. We will
Yeah.
complete next week. 5 sessions are for coverage and assertions. Okay.
Okay.
So Tuesday, Thursday, Friday, Saturday, Sunday. even at least 4 sessions I will take, 5 or 4. Okay, so that we complete the coverage. Next week onwards, not again next week onwards, we are going to start UVM lab sessions. Parallelly, Saturday, Sunday projects. Did you got the clarity now?
Yeah,
So
I
that
got it now.
by June end, UVM will complete, projects will complete. From July 1st, DDR. July 1st
Okay.
to DDR will take 2 months time. Okay.
And the ma'am, Verilog router and the system Verilog project will.
Sure, God. That's what only I am telling. Saturday, Sunday will be projects.
Okay,
By
okay,
processor
okay.
system.
UVM, including
Router.
SVM.
Yeah. Yes. Okay,
Yes,
whatever
ma'am.
the protocols are completed, just practice those first. Okay. Okay, then thank you all. Bye.
Yeah, thank you. Bye.